you give us the tape?
This is tape right here. That's it.
I'm thinking words like that.
I know you want to see.
Hey.
That's a little cheap roll.
Alright, through any 2 points, there is exactly one line. No, because y'all said you didn't know that. And we've been doing that since August. So no, tater tots. No. If 2 planes intersect, then their intersection is a line. A line contains at least
Oh, yeah.
if 2 points line a plane, then the entire
Plane.
line containing those points lies in the plane. Through any blank non-collinear points, there's exactly one blank. 3 and plane. Man, it's like we've learned something. Well, that's because you don't pay attention in class.
Good. I do.
No one's talking to you. If 2 lines intersect, then their intersection is a point.
Now it's
No. Again, we don't get points for this section because we said we didn't know what it was. A plane contains at least 3 non-collinear points. We did.
well, the first one is always.
And go
Well,
backwards?
sometimes.
That's always.
Yeah, I thought it'd be like.
Is it?
Yes.
But what if they're collinear?
It may be more than one.
So sometimes.
Get a point.
Take a point.
Well, Vanessa, you're such a
Alright, 3 points determine a plane sometimes because if they're collinear, then they don't determine a plane.
Never.
The intersection of 2 planes can be a point. Sometimes it's like the doohickeys up there, the bricks. Take a point, Mazzaro. There is exactly one plane that contains non-collinear points P, Q, and R.
But I was saying a different
It can be sometimes.
Because they're not. It's 3 non-collinear points that contain P, Q, and R. There is at least one plane.
Go to number 7.
Number 4. There are at least 2 lines through points M and N. Never. Through any 2 points, there is only one line.
Oh, that's always.
And number 5, if points A, B, and C line in plane M, then they are collinear.
No.
Sometimes.
Because it could be on a line or it could just be sent out.
Exactly. Pardon? I can. They could be on a line together, or they could be sitting out in the plane together. Being non-collinear. Chilling. Okay, so what we're going to do today is we're going to do algebraic proofs, which means that we are going to talk about our properties of equalities that you learned last year that are never fun, but we got to do it. And then we get to do proofs, which are actually kind of fun. Get excited. So, okay.
Get excited.
Then it was awkward. Alright, so the addition, now what we're going to do is we're going to start by writing examples for each of our, most of our properties. And then we're going to use some statements down there and we're going to start our proofs. Are you ready? The addition property of equality is when you add to both sides. So you would do that if you had A minus 3 equals 4. Because how would we solve for A? We would add 3, and therefore it's the addition property. You're confused? Pumpkin, if we solve for A, we add 3. That's the addition property. I taught you this last year.
You add 3 to both sides.
You said last year was last year.
Alright, so then for the subtraction property, we would have a plus 3 equals 4 because we would subtract 3 on both sides. Baby, I'm just making them up. At the beginning of the conversation, I said that we just making up examples. So, if we're trying to multiply both sides, what kind of problem would we have? A division, which is a fraction. Fraction. Who said fraction? Take a point if you said fraction. Don't lie. Don't lie. Because we would multiply both sides by 3. Alright, then for division property, that would be like, so it would look like 3a equals 4.
Divide by 3.
And you would divide by 3. Now the reflexive property means that they're equal to each other. The symmetric property means they swap places. The transitive property means you take out the middle and you have the ends equal to each other. Substitution means you plug in. How? Why? You just replaced. What you talking about? And then, alright, and distribute, that means you multiply, right?
I said distribute.
Thank you so much. Alright, number 1, state the property that justifies each statement. So if 5 equals y, then y equals 5. What does that look like? No, reflective is it's the same on both sides. Symmetric.
Number 4 is unreflective.
It is, but let's look at number 2. Number 2, the middle's taken out and the ends are put together. Transitive. Look at us go. Alright, number 3, what did they do to get 15?
They multiply.
No, they didn't. They subtracted. So that's the subtraction property.
Now it's reflexive.
Are you writing back there? Or doing anything for me to give you any kind of grade? Right, but we're having class. So are you writing down what we're doing today, pumpkin sauce? Is that what you're doing? Why don't you try doing that? Thank you. Alright, what is number 4? Reflexive. Alright, number 5. This one's a little tricky. Alright, so measure of angle M. That M means the measure of the angle. So measure of angle 1 plus the measure of angle 2 equals 90. And then it tells us that the measure of angle 2 equals the measure of angle 3. So what did they do? They plug in. And what property is plug in? Substitution. Look at us go. Good job, Tater Tots. Take a point.
No.
Alright, on number next, what did they do?
That's the
That's division. On number 7, can anybody tell me what they think that one is?
plug in.
No. Transitive. Take a point.
Distributed.
That is distributive. Do we agree or disagree?
Agree.
I hope you agree. Take a point, Trey. And the last one is addition.
What's that one is?
We need
What are you talking about? Okay. So what we're going to do now is we're going to do our first proof together. Get excited. Thank you for your excitement. So it is called a 2-column proof, which means it's going to have 2 columns in it. Dun, dun, dun. I would love that. That would be awesome. I'd probably cry. I'm not even going to lie. I'd be so happy. Be like, who made that? Okay, so, number 1, you're going to start by drawing 2 columns. I have a column over here and a column over here. It's called a 2-column proof. And on the left side is always, always, always your statements. And on the right side is your reasoning. So the reasoning is using the properties that we just learned. You just turn your paper. It's in your foldable. Like it's in the notes. Okay, look at you go. Alright, so you always start with the given. So what this is asking us to prove, we're trying to say that if 2 times the quantity of x minus 3 equals 8, then x equals 7. So you start with the given. The given is 2 times x minus 3 equals 8. And then over here for the reason, you write given. And now we're going to solve it, and we're just going to list our steps, and it's going to be awesome. Yes. Can anybody tell me what we do first to solve this? You distribute. Okay, so 2 times x is?
2x.
And 2 times negative 3 is?
2x minus 6 equals 8.
Fantastic. Take a point. If you answered at any point in that, take a point. Now what? Bless you. Get it together. Now what property did we use to do this? Distributive. Look at us doing our proof. I'm telling you. All right, what would we do next? We would add 6. And that would give us 2x equals 14. And what property is that?
Addition.
The addition property.
Then you would go to the division.
Baby, if I go any slower, we're going backwards.
Then you go to the division.
Wait. We pausing.
Then you go to the multiplication.
You had it right the first time. I was just asking you to wait so that he can catch up. So if you know what to do next, do it next.
How you write on this?
Yes, it is.
Alright, now, it wanted us to prove that if we have this statement, then x equals 7. Did we prove that x equals 7?
Yes.
Right, Q, E, D, and then you fancy and you're done. Like that. Because that's how you finish proofs. And when we get to geometric proofs, that's how we're going to finish it. And we're going to be fancy, and you're going to be ready for college, and it's Latin, and we're not doing all that. We're not explaining this. Yeah, if it's wrong, then you got to go back and see what you did. All right, ready? Stop.
I'm confused about number 4.
Why, baby? We divided by 2, so you write division.
How did you divide by 2?
Because it's 2 times x.
Where did you get that? Oh, did we use 2x? Did we use the statement?
We did use the statement.
No. But the 3. But how did you get 7x?
14 divided by 2 is 7.
Okay. Oh, and then you divided to do that. Okay. See, I got you.
I did not teach him last year, y'all. I take that statement back.
Yes, you did.
No, he was in 6th period. We spent 45 minutes each day on these. I don't know what's wrong back there. Let's look at number 2. Now, start by drawing 2 columns. On the left, you're going to write statement. On the right, you're going to write reasoning. Do this every time. What, baby?
I ain't gonna ask you.
Okay. All right. Now, This says that if 7 halves minus n equals 4 minus 1 half n, then n equals negative 1. So we're going to solve this. We're not going to be afraid of fractions. We got this. Always start with the given. So our given is 7 halves minus n equals 4 minus 1 half n. And what reason did we write that down? Given. Take a point. Alright, now, the first thing I personally want to do is move this negative 1 half n over here. So how would I do that? You would add 1 half n. And you would add 1 half n. And what property is that? Addition. Alright, so if you have negative 1 plus a half, can anybody tell me what that is? It is a negative half. Look at you go, pumpkin. Y'all, if you owe me $1 and you pay me back half, you still owe me half $1. That's all it's saying. And what reason did we add? I'm sorry, what reason did we give? Addition. Alright, can anybody tell me what to do from here? Subtract what? 7 halves is how we say that. What is wrong with you? Okay. And what's 4 minus 7 halves?
4 minus 7 half.
You have 4, you take away 3.5. How much is left?
2.5.
You have $4. You take away $3.50. 1 half. Sweet Jesus in heaven. And that's subtraction. Oh God. And what's the last thing that we do? How do we get rid of fractions? Multiply. What are we going to multiply both sides by? Negative 2. Got to get rid of that negative. 2 goes into negative 2 how many times? Negative 1. And what reason is that? Multiplication. Alright, homework. We're gonna start it off together. You're gonna finish number 3 without me. Now, let's draw our proof, the beginning of it, so that we know what it's supposed to look like. What goes on the left? What goes on the right? What is number 1 always?
Given.
And what did they give us?
Given.
Angle Y
It's congruent to angle Z. Now, do they tell us what angle Y and angle Z are?
Yep.
Yes.
What are they?
28.
We got x plus 10 and 2x minus 90.
So what would we use? If we plugged in x plus 10 and 2x minus 90, what reasoning is that? Substitution. Take a point. People who are still paying attention. Alright, tonight your homework is finish it without me. Clean up your towers. Don't leave stuff out. Y'all do it every day, and I'm going to take off all the points. Clean up your towers. And not higgly-piggly. I don't even know what to say to that.